Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter Combustion, Fuels and Flame. In this session we are going to see practice sheet 2 related to this chapter. Level 2 practice sheet which includes multi-correct answer type questions, comprehension paragraph, matrix matching, assertion reason, statement type and analytical approach questions. Okay, let us start this practice sheet now with multi-correct answer type questions. See the first one. Which one of the following is combustible? Combustible substance means what? The substance which burns in the presence of air or oxygen to produce heat and light is called combustible substance. See, which is combustible among these? A stone piece, will it catch fire? No. Paper, yes, it burns in the presence of air. Straw also will burn, even matchstick also. So these three substances will come under combustible material. Next one. Which of the following is a liquid fuel? See, fuels can be classified into three types based upon their physical state. Solid fuels, liquid fuels and gaseous fuels. Here some fuels are mentioned and asked to identify the liquid fuels among these. We know petrol is one of the liquid fuels. Diesel is also one of the liquid fuels. These two are derived from the petroleum. These are liquid fuels. And wax is a solid fuel and even wood also. So these two are solid fuels. Only here petrol and diesel are liquid fuels. Okay, next one. Explosion is the evolution of. So what are evolved when explosion occurs? We know when explosion occurs, heat, light and sound, these all are evolved, but oxygen is consumed there actually, isn't it? It is not produced out. So these three are evolved while explosion is occurring: heat, sound and light. Next, which one of the following is non-combustible? Non-combustible means the substance which won't catch fire in the presence of air even after heating it is called non-combustible material. Find out the non-combustible material among the following. Iron nail. Can it burn? No, it won't. It is a non-combustible material. Glass also, it won't catch fire even after burning also. Stone pieces also non-combustible materials. But wood, it catches fire on burning. So it is a combustible material. So the remaining three are non-combustible material which won't burn even after heating also. Right? Next one. Essential requirements for the production of fire. So what are the essential requirements for the burning of a fuel or burning of any combustible material? There are mainly three essential requirements for burning of any fuel or any combustible material. They are the fuel and sufficient heating, and next one, air or oxygen, sufficient amount of air or oxygen. These three are the essential requirements for producing fire from a combustible material: fuel, air and heat. These three are needed. Okay, next one. Next, let us say about comprehension passage type questions. First, let us see the passage. To extinguish fire, at least any one out of three essential conditions for the combustion must be removed. So as we told, there are three essential conditions for the burning of any fuel. So if you remove any one of these three, the fire can be put off. Fire can be removed. What are those three essential conditions for burning of fuel? Supply of fuel, supply of air and ignition temperature. These three are the essential conditions for the combustion. So if any one of these is removed, then fire can be put off. Fire can be extinguished. Now let us see questions on this. Fire extinguisher cut off what is the work of this fire extinguisher? It cut off the supply of air and bringing down the temperature of the fuel. Actually, these two are the works of a fire extinguisher. By these two, fire can be put off. Okay, these two are correct. Okay, when a fire extinguisher is applied, it will form a blanket around the fire causing material, and it cuts off the supply of the air to that, and even it brings down the temperature of the fuel below its ignition temperature, so it won't catch fire further. So these two are correct. Next, carbon dioxide is given off by chemicals like, yes, which kind of chemicals they produce carbon dioxide? Generally, the chemicals like carbonates and bicarbonates of metals. On heating, they produce carbon dioxide gas. Or on reaction with other chemicals also, they produce carbon dioxide. So here, one of them is given, that is sodium bicarbonate. Sodium bicarbonate on heating or on reaction with certain acids that produce carbon dioxide gas out. Okay, metal bicarbonates and carbonates, they can generate carbon dioxide gas on further reactions. Okay, here it is given sodium bicarbonate. That is correct answer. Next, water is not suitable for fire involving. Actually, water is used as a fire extinguisher. It brings down the temperature of the fuel below its ignition temperature, and sometimes it cuts off the fire also. But this water cannot be used as fire extinguisher in certain cases where the fire is involving oil or petrol or electricity. In those cases, water cannot be used for extinguishing fire. If the fire is caused by oil or petrol, if we pour water on that, we know water is denser than these oils and petrol. So when you pour water on the fire causing oil or petrol, it floats on the water and continues to burn. It won't stop the fire. It continues to burn even after pouring water also. Because water will go down, that oil or petrol will float on it and continues to burn. And in the other case, water also cannot be used as an extinguisher in case of fire caused by electrical equipments. Because if you pour water on that, we know general water is a good conductor of electricity because of impurities present in it. So if you pour water on that, the person who are trying to control their firing by pouring water, they may get electric shocks. That's why water cannot be used as fire extinguisher in the cases of fire involving oil or petrol or electrical equipments. Okay, now we can say this is the correct answer. Next one. Now let us see matrix matching type. So here about the different zones of flame. They have given matching. Their zone they have mentioned the column 1 and its characteristics is mentioned the column 2. Try to match this. Dark inner zone. So we know the flame of a candle can be classified into three parts: outermost zone, middle zone, and innermost zone. Here, the dark innermost zone is containing unburned vapors of wax, because for to that middle or innermost zone or dark inner zone there is no supply of air. That is why there the vapors of wax won't be burnt. That's why it is unburned vapors of wax are present in the dark inner zone. Okay, next let us see one more. Blue zone. Blue zone is the outermost zone of the flame. There, the vapors of wax are completely burnt with a sufficient amount of oxygen. So large amount of heat energy is produced there. And the wax vapors are burnt with blue flame. That's why there the temperature will be the highest, hottest part of the flame. No carbon is remained in that place. Fuel is or the vapors of wax are completely burnt in that outermost zone. So we can say It is a part where complete combustion occurring. Okay. Next, about luminous zone. Luminous zone is the middle part of the flame. In the middle part, the vapors of wax are partially undergone combustion because insufficient amount of oxygen is supplied to that part, to the middle part. So the vapors of wax are partially undergone combustion and the flame will burn with yellow color. That is said to be luminous flame. So partial combustion is occurring at the luminous zone, that is middle zone. Next, non-luminous zone. The outermost zone of the flame is non-luminous, where the vapors of wax are burnt with blue color. So that is said to be outermost zone, and that outermost zone is the hottest part of the flame, and it has complete combustion of the vapors of the wax. Okay, this is the matching. Observe once different zones and its characteristics, what is happening in the flame. Darkest zone or dark inner zone is the innermost zone where vapors of wax are being unburnt, and the blue zone is the outermost zone where the hottest part in the flame and where the complete combustion of vapors of wax undergone. Next, luminous zone is the middle zone where partial combustion of vapors of wax undergone. Okay, it has a moderate temperature. Next, non-luminous zone is outermost zone again where complete combustion of vapors occurs. Okay, this is matching. Next, now let us see statement type questions. See the first one. Statement 1. Air is a supporter of combustion. Is it correct? Yes. Air is a supporter of combustion. Air in the sense the gas present in the air is oxygen. It supports the combustion. So in the presence of air only any combustion occurs. So we can say air is supporter of combustion because of the presence of oxygen in it. Next statement. Air is not supporter of combustion. This is not true. Air is supporter of combustion. What we can say now? Statement 1 is true, but statement 2 is false. This is the correct answer. Next. So if you see next question, statement 1. Inflammable substances have low ignition temperature. Inflammable substance means the substance which catches fire at a low temperatures itself, and they undergo rapid combustion are called inflammable substances. So these will be having ignition temperature at low. So they have low ignition temperatures, that's why they can catch fire easily. That's correct. Now if we see statement 2, coal is an inflammable substance. Is it true? No. Coal is not an inflammable substance. It won't catch fire easily. It is to be heated to a high temperature. Then only it starts combustion. So coal is not an inflammable substance. Statement 2 is wrong. Statement 1 is true. Statement 2 is false. So this is the correct answer. Okay. Next one. Now let us see assertion reason type questions. See the question. Assertion. The slow process of conversion of a dead vegetation into coal is called catenation. Is it correct? Yes, the slow process of conversion of dead vegetation into coal is called carbonization, not catenation. It is wrong. And the reason given, when heated in air, coal burns and produces mainly carbon dioxide gas. This is correct. When coal is burnt in the atmospheric air, it produces carbon dioxide gas. So it is correct. Now what we can say, assertion is not correct. Reason is correct. So here it is. A is wrong, or is correct. Next, one more assertion reason type question. See the assertion. Petroleum is called black gold. Yes, it is correct because of its different purposes and usage of this petroleum. It is called black gold. And reason, due to its it is given here reason directly. Due to its great commercial importance, petroleum is called black gold. It is also correct. So both are correct, and R is correct explanation for A, where it is here. Okay. Next, one more analytical approach type questions. Arrange the following fuels in the increasing order of their calorific value. See, certain fuels are mentioned here, and they're asking to identify their calorific values, and they ask to arrange them in the increasing order of their calorific value. Means the fuel with the lowest calorific value should come first, and at last should be the fuel with the highest calorific value. It should be 3 actually, 2 times 2 given. Okay, now see petrol, wood, coal and natural gas. If you observe once these all fuels, out of these all, only one gaseous fuel is there. We know gaseous fuels are having generally high calorific values than the higher calorific values than the solid and liquid fuels. So this will be having the highest. And next liquid fuels if we observe. Next petrol is there. So we can say this is the one with the highest calorific value. Next, next petrol, and next there are two fuels. One it is wood and coal. We know coal is a processed dead vegetation, so it produces large amount of heat than wood. Finally, least calorific value among these all for wood. So in this order they should be first fourth one wood. So 2, 3, 1, 4. Where it is 2, 3, 1, 4. This is the correct order of fuels with their increasing order of their calorific value. Calorific value means the amount of heat energy liberated when 1 kg of fuel is completely burnt is called its calorific value. Generally, gaseous fuels are having the greater calorific values than liquid fuels and even solid fuels too. Okay, this is about calorific values. Next, one more question. The total amount of heat produced by a fuel having a calorific value 20 kilojoules per kg was found to be 50,000 joules. How much fuel was burnt? Once you observe the question again, they have given the total energy produced as 50,000 joules. So 50,000 joules we can convert into kilojoules. That is 50 kilojoules. And even they have given the calorific value of the fuel also as 20 kilojoules, means the amount of energy liberated when 1 kg of fuel is burnt, that is calorific value, means by burning of 1 kg of that fuel it produces 20 kilojoules of energy, and by combustion of the certain amount of fuel it produces there 50 kilojoules of energy. Now they're asking to find out the mass of the fuel, total mass of the fuel burnt to produce 50 kilojoules of the energy. How can we calculate total energy produced? By the calorific value of that fuel gives the mass of the fuel burnt. So the total energy is given as 50 kilojoules energy produced, and its calorific value is given as 20. Substitute those two, we get the total mass of the fuel burnt as 2.5 kgs. So by burning of 2.5 kgs of fuel, it is producing the 50 kilojoules of energy. Where it is 50, 2.5 kgs, here it is. Okay, next question. See, one activity is mentioned here. Radhika took some sodium bicarbonate in a conical flask and set up the apparatus as shown in the given diagram. She added concentrated sulfuric acid to the conical flask using a funnel. Okay, what she did? She has taken sodium bicarbonate in a conical flask. She arranged to hold rubber cork to that. And into one rubber cork, she kept a funnel. Into another cork, a delivery tube is connected. If you observe here, this delivery tube is the other end of the delivery tube is kept in a beaker in which a candle is being burnt, start burning. A flamed candle is kept here. Now into this conical flask she added sulfuric acid. So what happens now? The sulfuric acid reacts with sodium bicarbonate. Actually, this is the experiment which is happening in the soda acid fire extinguishers, isn't it? These soda acid fire extinguishers contain two containers inside. Actually, it seems like a single cylinder, but it contains two containers inside. By pressing the nozzle, the chemicals present in the two containers they react each other at nozzle. The chemicals are, one is a sodium bicarbonate, the other one is sulfuric acid. When these two react each other, they form sodium sulfate, water, and carbon dioxide gas. These all will mix and form a foam-like substance. Now, so here the gas is evolved out through the delivery tube. What is the gas produced in this reaction? We are telling carbon dioxide. Now let us see options what they have given about this. Here are the statements given. So they mentioned about the gas here. What are the characteristics of this gas produced here? The gas coming out is of the delivery tube is heavier than air and will make the candle glow bright. What we are telling here, the gas evolved out. When sodium bicarbonate reacts with sodium sulfuric acid, it produces carbon dioxide. We know about carbon dioxide as it is heavier than normal atmospheric air because the vapor density of carbon dioxide is what is it? 22. Generally, vapor density is calculated by taking the formula molecular mass by 2. Molecular mass of carbon dioxide is 44. So by 2 it gives 22. Whereas for the normal atmospheric air as it is a mixture, it is calculated by taking the average of all and it is found as 14.4. So we can say carbon dioxide is much denser. It is heavier than atmospheric air. And one more property of carbon dioxide is it won't support the combustion. We can say it is a non-supporter of combustion. Okay, so it puts off the flames. It is used as extinguisher for controlling the fires. So it extinguish the candle flame if it is blown on it. Now see which statement is giving correct properties of this carbon dioxide emitted out. The gas coming out of the delivery tube is heavier than the air and will extinguish the candle flame. Where it is, if you observe, this is correct statement, isn't it? The gas coming out of the delivery tube is heavier than air and will extinguish the candle flame because the gas coming out of the delivery tube is carbon dioxide. It is heavier and it comes down, and it is a non-supporter of combustion. Immediately extinguishes the candle flame. Okay, that is correct. That is about the level 2 practice sheet on the chapter combustion fuels and flame. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.